Let's begin. Today's December 15th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 5, 9, 13, 16, 21, and 22, and the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card B will take a look at the 3-digit solution, and the Turing Machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2, maybe even all 3 are 3. Criteria card C will take a look at our middle and last digits, square and circle, and compare them. So should the value of square be less than circle? Should they be equal? Or should the value of square be greater than circle? Criteria card D, again, will take a look at our 3-digit solution, except this time it'll inform us a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card E, again, takes a look at the 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 2 cases. One where the 3-digit solution has a pair, as in the example 131, or alternatively, there are no pairs, but there are 2 scenarios. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F, again, takes a look at the 3-digit solution from triangle to square to circle, and will let us know a little bit about the ordering of the digits. Should the digits appear in an ascending order, meaning that they are increasing, as in the example 135, or should they appear in a descending order, basically decreasing, as in the example 421, or could they have no order? So let's take a look at the example of 231. Notice that it goes from 2 to 3, then 3 to 1. And from 2 to 3 it increases, and then from 3 to 1 it decreases. Of course, you could also have a solution that is decreasing and then increasing, but it's basically that shift from one direction to the other that defines a 3-digit code to have no order. Now, we have seen in other puzzles the following scenario where if you have consecutive equal digits, that can also exhibit no order. So if you take a look at the example in criteria card B, the 331, notice that the 3s are equal, and of course they're consecutive, they're next to each other. But if you go from 3 to 3, there is no change. It neither increases nor decreases. So that's what I meant when I said that consecutive equal digits would exhibit no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card A. Okay, so the Turing Machine does not approve of my choice in triangle. I did pick an odd 3, but because the Turing Machine does not agree with that, it's actually informing us that triangle should actually be an even digit. So let's go ahead and type that up in our notes in section A. And again, we'll say that triangle is an even digit. And of course, since it is even, let's go ahead and cross out the 3 odds. Okay, I think the next thing I'd like to test is criteria card D. Okay, so the Turing Machine does not approve of my proposal, and criteria card D, we are examining the ratio of even to odds. So in my proposal, I do have 2 odds to a single even, but since the Turing machine does not agree with that, it's informing us that there in fact should be more even than odds. So let's go ahead and type that up in our notes in section D. And we'll say that the solution, we'll say that there should be more even than odds. And in combination with what we discovered from criteria card A, well, in A, we established that triangle is even because there are to be more even than odds. That means you should have at a minimum 2 evens, or potentially 3. So we could be looking at an all even solution, or if we do have 2 evens and an odd, then either square or circle should be even and the other odd. So that's something to kind of consider going forward. Let's see what else. I think I'll test criteria card C next. Okay, so again, the Turing machine does not approve of my choice in criteria card C. We are comparing our first and last digit, our middle and last, the square and circle. Well, in my proposal, my square value of 1 is smaller than my circle value of 4. But since the Turing machine does not agree with that, the alternatives are that they are equal to each other, or possibly square is going to be greater than circle. Well, let's go ahead and type that up in our notes in section C. And we'll state that square is either equal to or greater than circle. Okay. And let's see, I think because of the equal possibility, I don't think we can actually cross anything out. So I think that's how our board remains. Remember, well, this does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card B, querying the number of 3s. Well, at this point, it's we might have an odd potentially. If it's odd, it could be a 3, or it may not. We still do have outstanding the comparison between our middle and last digits, square and circle. We did not test criteria cards E, where we could determine whether there's a pair or not. And we also did not test criteria card F, where we would discover something about the ordering of the digits. Well, if you've seen some of my previous videos, I believe we may be able to deduce criteria cards E and F. And I believe the argument is as follows. If we were to presume that the solution were in ascending order, so not only would the digits be increasing, but they would be increasing in a way where they would be all distinct. So by definition, increasing means that you're not going to have equal digits, next to each other. So if it's ascending, that would include the idea that there should be no pairs, making criteria card E irrelevant. Likewise, if it's in a descending order, the only distinction is it's in the opposite direction. They are getting smaller, but uniquely smaller. Nothing where consecutive digits would be equal. Again, that would inform us that the solution would also have no pairs, again making criteria card E irrelevant. So we can then deduce that the solution must have no order. So we'll type it up as we're going to deduce the solution has no order. And I think we can make a similar argument in that if we do have a pair of digits, as I mentioned at the top of the video, regardless if the pair of digits are consecutive or next to each other, as in 331, or of the form of 131, where that middle digit separates the pairs, both of those examples would exhibit no order. So if you presume that there is a pair, then it would make criteria card F irrelevant, because you would know that they would have no order. So it's safe to deduce that the solution should have no pairs. So let's go ahead and type that up in our notes, and we'll say we're going to deduce the solution has no pairs. And so that would mean that we are looking at unique digits, and because we've already established in criteria card D that you do have a majority of evens, well, now we've established that there can only be two evens because of no pairs. So that means that our solution is going to be a 2, a 4, and an odd. Of course, we don't know the order, but now we've established that, yes, we must have a 2, a 4, and an odd. Okay, so we go back to criteria card B, and now we know that if there is a 3, fantastic. There can only be one, but the other possibility is that there is no 3, therefore forcing that odd digit to be a 1 or a 5. So we'll see how that plays out. And now that we know that there are no pairs, well, we know from criteria card C that square and circle cannot equal each other. So let's go ahead and cross it out, or at least this possibility. And now we've established that square should actually be greater than circle. And I'm just going to add a note here that we've deduced that relationship between square and circle. So let's go back and see, how does that affect our values? Well, if square is to be greater than circle, then I think it's safe to say that square cannot be a 1, because if square were 1, there's nothing smaller that circle could be. And similarly, I think we can make the argument that circle cannot be a 5, because if circle were 5, there's nothing greater for square to be. So let's see if we can cross out that 5 value in triangle. And so, yeah, now it looks like not all, but there are glimpses of where square will be greater than circle, basically following this diagonal. Okay, and remember, one of those is even, the other must be an odd. Whether it's 3 or not, it's hard to say. So let's see. So we do have a 2 and a 4. We have no order. So let's see, what else can we... Well, at this point, it seems like everything is very well established. The only thing is there a 3 or not? So very interesting. So let's see, what if, let's make the argument, well, yeah, so now, at least in circle, there is a 1 or a 3. And so let's see, what if there were no 3s? Well, there's also a 5 in square. I just noticed that. We are looking at no order. So let's see. Well, let's approach it from triangle. What if we let's start off with triangle, perhaps maybe being a 2. So if there is no order, of course it's going to be 3, 4, or 5. If it's a 4, let's see. So the question is, yeah, how do you force either square or circle to be even? What would that mean? Well, again, if there are no 3s, then we have 2 choices. Either there is a 1 or a 5. So it could be 2, 4, 1. If there are no 3s, of course. 2, 4, 1, or 2, 5, 4. So we have 2 possibilities if there are no 3s, and triangle is 2. 2, 4, 1, or 2, 5, 4. Okay, so that's a possibility. What about if triangle were 4 and there are no 3s? So it could be, well, in that case, if there are no 3s, it couldn't be 4, 2, because 1 would be descending, and then the others would be no duplicates. So 4 is not a possibility with no 3s, meaning 4, 2, sorry. But 4, 5, then it could be 4, 5, 2, with no 3s. And with a 3, oh, maybe with a 3 it's not possible, because if it were 2, 3, well, no, I guess it could be 2, 4, 3. I was going to say 2, 3, 4 is not valid because that's ascending, and 4, 3, 2 is invalid because it's descending. So 2, 4, 3 or 4, 2, 3. Oh, that's interesting. I wonder if choosing a 3 would be ambiguous yet. Oh, but we do want square to be larger than circle. So that would mean that it would be 2, 4, 3. I think that might be the only possibility. Yeah, because I may have said 4, 2, 3, but that's not correct based on criteria card C. I guess it could be 4, 5, 2. Yeah, this having a 3 is rather tricky. There does seem to be a few more where there are no 3s. But let's see, how can we... Again, we've got to force that triangle to be a 2 or a 4 in some way. So let's see. If it's 4, 2, it can't be 1. If it's 4, 2, it can't be 3. So it looks like, well, that's 4, 2. 4, 5 will still work. But not 4, 3. So there seems to be too few potential solutions with a 4 in triangle. So let's go ahead and say 2. Let's say 2, 4, 1. And let's see, how can we, again, how do we force these possibilities? What forces triangle to be a 2 and square be a 4? Let's see. 2, 4, 1, 2, 5, 4. There is no 3. Yeah, let's do the following. Let's do 2, 5, 4. There is no 3. And that would sort of force, well, let's see, would it? 2, 5, 4. Would that force triangle to be a 2? There is no 3, 4, 2. Yeah, let's do that, 2, 5, 4. And just to double check, the first digit is even. The middle digit is larger than the last. We do have a 2 and a 4 and an odd. There are no pairs, and it's no order. That is correct. Okay, well, let's try that out. And again, we've outright deduced E and F, so there's no need to test that. We have to establish whether there's a 3 or not. And that really is, that's interesting, that it really falls to just knowing if there's a 3. Everything else has been well established. That's very interesting. All right. So no, it does not like the fact of the absence of a 3. Interesting. Okay, so let's go ahead and type. We are going to deduce at this point because we know there's a single odd, and it did not like the absence of a 3. So we're going to say we're going to deduce the solution has a single 3-digit. Okay. And because we do have a single 3, let's go ahead and cross out the 5 and the 1. And then we'll discuss which of the 3s it might be. Okay. All right, so no 5, no 1. And so now let's see. Well, if there is a 3, I don't think it'll be the middle, because in both cases you're forced to either have an ascending or descending. So 2, 3, 4, 4, 3, 2. Is that right? If square is 3, yeah, it forces you to pick that diagonal. So yeah, so I don't think that middle digit square is going to be our 3. And so, and because we do have square needs to be larger than square, well, I don't think circle could be the 4, because 2 is not bigger than 4, and neither is 4. So yeah, you have to take 4 off from circle, and that's our only 3. So that means circle can't be a 2. Okay, and the only thing that's larger than 3 is 4. So that means square cannot be a 2. And so that means that triangle has to be the 2, and square is not the 4. All right, so let's quickly review. It looks like our solution is 2, 4, 3. So yes, obviously that first digit is even. There is a 3. Our square value is larger than circle. Yeah, 4 is bigger than 3. We have 2, 4, and an odd. No pairs and no order. Yeah, it increases, then decreases. Yeah, so it looks like 2, 4, 3 should be our solution. Well, let's go verify that 2, 4, 3 is correct. Two, 4, 3. Fantastic. Okay. Well, how do we do versus a Turing machine? Well, this puzzle is a 6 criteria card puzzle, and we did only 4 tests. They were all wrong, though. Interesting how even incorrect answers will lead us to the correct answer. Fascinating. Okay, well, let's type it up. We did do A, C, D in the first round, and then B in the second, and we outright deduced E and F. So let's type that up. A, C, D in the first round. All incorrect. Just so interesting. Obviously, we are learning something from each incorrect choice. We begin to remove possibilities until only one remains. Well, awesome. So we beat the Turing Machine by 2 questions. Well, that was a little bit to be expected, specifically because we were able to outright deduce E and F. It is beginning to become apparent the more puzzles that we see where we have criteria cards E and F. They play against each other, and we've begun to incorporate that in our solving. So if you ever do see it, I will, I think for the foreseeable future, as long as I don't forget, I will be skipping criteria cards E and F in the first round and looking at the other remaining 3 to 4 criteria cards to get more information. Okay? Well, fantastic. How about you? How did you solve it? Did you recall that how criteria cards E and F play against each other? Or what order of criteria cards did you pick? And did you find anything else interesting in this puzzle that you'd like to share? Add those thoughts to the comments. If you did like the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.